All right, the doors are closed, so I must be signed to get started here. My name's John, so I'm with SaltStack. I'll be moderating today's panel discussion where the focus is around DevOps and continuous deployment. We've got a nice panel up here that'll give us their experience on things. It's a pretty loosely defined agenda and purposely done so. I think the important part of these panel discussions and what we want to leave plenty of time for is towards the end to give everyone a chance to interact, ask some more questions from the panelists here, and give you guys a chance to share your experiences as appropriate. So we've got Andy Fundinger here from Risk Focus, Alex Schwartz from MSG Systems, and then also Eli Ribble, CTO of Authentise. So I'll let them introduce themselves. So the agenda is going to be, we'll let these guys introduce themselves, their organizations, talk a little bit about their backgrounds as it relates to DevOps and continuous deployment. And then we'll get into, we've got a few questions that we've put out there for them to talk about as it relates to their organizations and how they approach DevOps and continuous deployment. This is a little bit of a kind of continuation for those of you who were here with Andrew in the last session. So we've kind of purposely kind of stacked those back to back, as well as on top of some of the keynote topics from this morning. And then we'll go into a open Q&A for the last 15 minutes or so. So, and Celeste, I'll ask Celeste to walk around with the mic or something to give everyone a chance to ask questions. So with that, we'll go ahead. I'm going to pass it over to Alex here, and then we'll give everybody a few minutes to introduce themselves and also their backgrounds and go from there. So, Alex.
Hi, I'm Alex. I'm working for a company called MSG that's, has been founded 30 years ago in Germany. We are about 5,000 employees, like 3,000 based in Germany and the rest all over the world. Yeah, and we're doing IT software systems for SAP, for other companies, Java software development, .NET software development. I started out like 10 something years ago being a professional software developer. Back then, these days were you run it, you build it, you run it. Was a small team developing online banking software for a small online bank. 3 to 4 people we were at that time. After that, I worked for a bigger bank, so the team grew to a size of about 15, 20 people. There were first like segregation of duty, more red tape coming. And after that, I joined MSG Systems, and it's now in a way that, well, we build software for our customers and they run it themselves. So it's kind of more like an air gap to IT operations. On the other hand, over time I saw a very great development in tools. So maybe it's unlike some other people here. I feel in a situation that today I have a great tool to do continuous development, but I have an organizational structure that is sometimes a bit or very challenging when it comes to DevOps. All right. That's about me.
How about we go to Eli next?
Sure. Okay. So I'm Eli Ribble. I'm CTO of Authentise. In a previous life, I worked for a company that did mobile device management. That was back in the good old days of Windows CE and Windows Mobile, managing devices for very large companies like FedEx. And so it was sort of configuration management, but for devices that would be in someone's hand. After that, I went to another company that did some online video and interaction stuff. So we were deploying to multiple data centers all over the world to try to reduce latency in video communications, as well as online collaborative editing and coding and that sort of thing. Currently at Authentise, what we do is 3D printing software. So we help people who own models, that they do the design of the model, connect with people who own printers that want to print those models. So they pay the owner of the model for the rights to print that object, and we supply software that will configure their printer. It will securely stream that model to their printer. Various other services all around 3D printing. I have to get into the details to be interested, but my team's actually quite small at this point, but it all comes down to managing online services reliably. And so it's interesting. Our challenges, I think, are exactly the opposite of Alex's. I have an extremely small team, and there's no red tape whatsoever. And it's all about how quickly we can leverage tools and processes to take my very small engineering team and supply the latest cutting edge, because 3D printing is moving very, very fast. And so we have to iterate very quickly in order to stay on top of the latest developments and supply real value to people that, by and large, are developers often much smarter than me and my team that are doing some of this really cutting edge work. Thanks.
So I'm Andy Fundinger. I'm from Risk Focus. We're solution providers to the financial industry. So we generally bring a team of experts to work with our clients to solve their problems. So often, if we're just dealing with an internal problem, it's very simple. We're about 50 people. We're almost 100% development and absolutely 0% ops. So if something's being done that's ops-like, it's a developer going and doing it. But the challenges in our industry are around long-term systems that have been in operations for a long time, and legitimate silos that can't just be broken. So a system in the financial industry might be out there in production for 5, 10, 15, 20 years. They might actually stop development. If there is development, they might be over in some little section, and nobody understands the core as an active working knowledge. So when they go to a DevOps tool, then operations has to do it, and operations has to justify it because it makes operations easier without any of the benefits to development, because there is none. And then you have those legitimate silos of either experts in the 120-year-old technology or a regulation that says, no, you just can't edit the code and log into a production server, period. So let it be written, so let it be done.
Thanks, guys. So that's probably a good introduction to really our first question, which is really around the balance between dev needs and operational needs within an organization. And Andrew talked about it this morning. Tom touched about it in the keynote a bit. I think organizations are trying to figure out how they deal with this growing need, this growing DevOps needs. And in the organizations, sometimes they deal with it. Some organizations choose to deal with it by involving their IT organizations and passing that on. Some organizations may not be big enough to have separate IT organizations, and they've got to learn to deal with it internally within that development organization. As you guys have varying experiences and backgrounds, how have your organizations dealt with this DevOps need? Is that something that you guys handle internally? You guys involve IT with? You guys collaborate with IT to work together? How do you guys meet some of those needs? And maybe I can start at the other end with Andy this time, since we kind of started that conversation already. How have you guys started to meet those challenges with yourselves or with your customers?
So, yeah, for ourselves it's pretty easy. But for our clients, what we need to do is something especially that can be pushed out piecemeal. And because they have a little bit, they have a very low interest in putting investments. So we're looking at something like Cloudify or Deploy XL, where each system can adopt it one by one. And then our second part is to use something like, and this is where we use Salt. We take those experts that we have, because we have enough of them to keep the system up, our clients do, and have them make a Salt state to encapsulate their knowledge and really hold it and let that be used throughout the organization.
So what I found in my experience is that the tendency organizationally will be for developers to want to say, it worked on my machine, I checked it in. I don't know, I'm not an expert. I didn't stand up the servers. You got someone to figure that out, right? And so the thing for us has been, we have to have buy-in from the very top to say, no, we don't have IT people. We don't have someone whose sole job is to take your code as nicely packaged up as it is, and deploy it with angel wings and all that stuff. It's to say, okay, what's your estimate on how long it'll take to get this job done? And they say, oh, it'll probably be like 3 days. And then you say, okay, great, what's your deployment strategy? What's your testing strategy once it's deployed? How are you going to ensure that what you built is what is actually running, is what is our customers are experiencing? And then they go, okay, well, maybe more like a week. And then when you get to that point, they come at you and they'll tell you, well, I tried to deploy and it didn't quite work. And the implication is, find someone to fix this problem for me because it's really not interesting. And you have to have the organizational discipline to come back and say, this is part of your job. We don't have IT people. You are creating this new benefit for our customers. It is your responsibility that they get it in their hands, which means you have to figure out what the problem is and you have to solve it. And it takes a lot of discipline to keep doing that because eventually someone will get very expert at it and they can answer all the problems, they can fix everything, and you have to encourage them, teach everybody else. Don't do it for them, teach them. Be very open to, okay, well, that was an interesting approach, to write a bash script that you're going to deploy, and then that's going to actually do everything. But we can actually do this with Salt. We can write states, and we can have all this stuff checked in a idempotent way. And let me talk to you about the way that these things work, the way the reactor works, and all this stuff. So it's a very, for us, it's very people centric. It's education centric. It's deciding that is important to your culture and constantly pushing that in your culture.
Thanks, Alex.
Yeah, for me, it's, as you might have noticed, I'm from the development things of not of the IT operations side of things. And for me, it starts with the great tools that we have today on the development side of things. So having Vagrant, having Salt, having the chance to do a masterless setup of a development environment, every developer working on its own database. I think 10 years ago, 5 years ago, no one could really have imagined that you have an Oracle database running on your local machine. But that's true now, if you still have to take an Oracle database, but then. So we have very great tools and great procedures to automate things on the developing sides. But the big organizations that you also talked about, financial organizations, or in my world, it's logistics, the common ground that you meet with IT operations is then sometimes, oh, yeah, RPMs. What about RPMs? Why don't, and then the purchasing providers of that big companies, they have outsourced all of their IT. They've written up lengthy contracts with their IT outsourcing providers to describe how to hand over that piece of software. And in one of these cases, it boiled down to, well, we would like to have an RPM plus an Excel sheet to be filled out to hand it over to IT operations. So that's my world in some places, but still you can do really good automations on top of that. And I found that even if in a such difficult environment, you can do delivery that is fully automated. You can even automate filling out Excel sheets, and that worked very well for us, like a Maven plugin, filling out Excel sheets to comply with that process. We follow that process by the letter, but still make very happy IT development and IT operations team, because we hand over packages that just install. We have lots of automation in our Jenkins and building RPMs, developing to test and create environments that are within our MSG company, and then at the end hand over an Excel sheet and an RPM to our IT ops. And that's my experience.
Thanks, guys. So as we talk about some of these operational best practices, part of the goals are to really achieve better reliability, better scalability within your organization, within the products that you guys support, within the customer environments that you support. Can you touch on that a little bit more as it relates to what from a process standpoint, from it could be a tool standpoint, your experience in achieving better reliability, an ongoing continuous development cycle for better reliability, better scalability. What does that look like within your organizations or successful organizations that you've worked with? And I'll pass it back to Alex here.
Thinking about reliability, that's for me usually automation. Automate all the things. Well, heard maybe too often. But then I don't know, maybe somebody wants to raise a hand and say, who believes that developers can package RPMs? Can? Okay, how many then say how many IT developers should package RPMs? More than they do today? Okay, some hands there. I was skeptic at the beginning about packaging RPMs, and the spec files are kind of, well, I don't like them too much. But there are tools around that. There's effing package manager. For example, if you just want to have a command line to package a package. So reliability comes with automation. That's one thing. And scalability comes with having every developer having its own development environment, its own database. That's where I, as a developer, heading other developers, see really the chances for us to scale. Everybody has its own development environment, and scale also in terms of it's so automated to install software that you don't need to read, well, a 10-page or 20-page manual, that you don't need to train the installation of a piece of software in a development or in a staging environment 3 times until you can be really, really sure that it works in production the same way. Yeah, that's for me, these 2 words.
I think a lot of the keys to reliability and scalability come down to codifying the information that is kept in the various engineers' heads. Many of us have gone through the pain of some engineer coming to us and saying, you know what, Google offered me an enormous pile of money and I'm going there in 2 weeks. Thanks, it's been really great. And like the blood drains out of your head and you realize, oh my gosh, this is the person who's been keeping my business running for years and I can never drain all of that information out of their heads. And so if you look at the progression of, well, I would love it if I could just get that person to write everything down in a book, and then everyone else could read it, and then they would understand it. And then you think, well, a book there's going to be some things lost in translation. It would probably be better if I could get them to like write it all down in code. Well, and then it would be even better if that code were something that other people could build on top of, right? And you just walk down this line of, I want to get to the point where we are codifying everything that is organizational knowledge, right? You want as much information to be passed around as possible, and the most dense form you can pass that information around in is these are literally instructions for how a computer can build our system. And you have to get that stuff nailed down first before you can even really approach reliability, because if you don't know the processes that went into producing your product, then you don't know the processes needed to reproduce your product or to scale your product up. And so it all starts with that codification, and it all starts with really pushing on the idea of our organization grows because the information and the knowledge in it grows, and the best way to grow that is by codifying everything that you can. Also, it comes down to engineering discipline. If you've got a server 1 out of 100 that fell over for some reason, true engineering discipline is to be able to dissect exactly what happened, the situation it was in, the configuration that it had, the code that was running on it, and dissect all of that and figure out, okay, what exactly happened that made this fall over? What assumption did we violate? What process was out of line? In order to do that, you need to understand everything that went into that environment. And that, again, comes down to codifying things. Thank you. So I think really software engineering is all about, can we reproduce it? Can we analyze it? Once we analyze it, make the correct decisions on it, then iterate and do it again and again. That is engineering discipline to me. And that all of that comes down to codification.
Okay. So beyond that, because that's covered territory excellently well, one thing that's really interesting to notice is that reliability and scalability are very, very application and architecture specific. What needs to be reliable and what needs to scale is very specific to, are you doing a compute platform? Do you need it to be scalable that if you throw 10 times as much hardware on it, it gets 4 times as fast? You do need to be able to repeat so that you can add 10 times more hardware or bring up your disaster recovery site. Those are always going to be there in some fashion. But also the developers need to sit down. They need to understand what reliability and scalability are in their problem domain. And this is a case where you're probably going to have to be making some calls from the running application into the infrastructure to say, for reasons that are entirely opaque otherwise, I am panicking, I need more hardware, I'm running behind, this is not working right, but it's a problem domain thing that the CPU's not spiking, memory's not spiking, it's just gone off the tracks.
I think that's one of the important things about codification as well, is because you can have, I don't know if this has happened to anyone else, but it's happened to me. You have a developer come to you and they say, so I just redesigned the way our message queuing system works. We can handle 10,000 messages per second. And you go, that's really cool. You're aware that at peak, we do about 100 messages a second, right? Oh no, I hadn't really measured that. Yeah, well, you just optimized for completely the wrong thing. We actually don't care about our message throughput at all. What we do care about is our CPU utilization, and your new architecture requires 10 times as many servers as we had to have. Like, you have to like measure the stuff and know what metrics matter. And I think that that really starts with, you reproduce your system, you try some different metrics, you change some configuration, you go, okay, what metrics changed, and when did the thing fall over?
Excellent, guys. So the last structured question that we have here revolves around the various tools that are out there in the marketplace these days. We had quite a few of those sponsor SaltConf, and SaltConf or Salt itself is another one of those tools that people use within DevOps environments and IT operations environments. But as you look at the plethora of tools that are out there that are available to you now, coordinating, orchestrating them all. You talk a little bit about your selection process for some of these tools that really best of breed, just good enough but easier to manage. Talk a little bit about your process for and your thoughts around this tool ecosystem that now exists out there within the environment. And maybe if I can start with Andy, is that all right?
Sure. For ourselves, internally, this is as easy as adding a library. Couple developers take a look at it and we can attach it to an internal project. Now, for our clients with the much larger environments, it's a lot more complicated. And what they have to look for is a minimal investment, maximum initial return, and then a wide interoperability. And investment here is not just what it costs. Costing itself can be complex because they may have agreements that already bring in things. But also, they have to get it through validation, they have to get security approval, and so on. And then, likely, it's going to be some portion of operations applying it to some system, and they need to justify that with a significant return, saving some trouble, etc. And the key here is that it has to be something they can bring in piecemeal, because a lot of the tools, they're going to benefit if they put it across their whole organization. But there's a lot of systems, and they're not all open for investment. So we're very much looking for, can we bring in one tool that people can adopt over 5 years and get benefits? And by the way, will it support AIX? Because it's still running around.
Our process is pretty different because we're so small. We mostly run Python, and so for the vast majority of what we do, installing a new dependency is as easy as pip install whatever random thing I found on the internet, which is cool. Python's cool that way, but it's very dangerous because most of the costs around bringing in new tools or new dependencies are about knowledge transfer and about getting everybody use the same thing. Because it is just as bad to have 14 different services in your company and each one has completely different dependencies as it is to spend 6 months just doing R&D building libraries that everybody uses. Like, they're both very expensive, even though one of them looks like it's almost free, because every person can be like, oh yeah, I'll just pip install this thing, this is cool, I found it on GitHub, all right. So one of the things that we employ is very careful code reviews, obviously. Anytime someone does import something and we don't recognize it, it's like, whoop, red flags, hit the klaxon, go crazy. All right, what is this thing? Why are we bringing it in? What does it do? But that's because we have a small team. And everyone's got skin in the game for like, okay, I have to understand how this crap works. Like, if you can't teach it to me in less than 15 minutes, no. The other thing is when we're looking for tools like, say, a Jenkins or something else, something that's not really like code related but more workflow related, the biggest thing for us is time boxing. Some developer would be like, I was dealing with Jenkins. It was kind of a pain. I'm not really sure what to do. I'm looking at these plugins. I'm thinking maybe Gradle something. And I'm just like, wait, whoa. And they can spend days looking at exactly the right tool that fits in exactly the right way. And is it extensible? And it's got Lua scripting built in and all this crap. And generally, it's most effective when I tell developers, okay, what's the problem? They explain it to me. I say, okay, you have 3 hours to come up with what you think the right tool is. And you time box it really, really hard, and then they come to you, and sometimes they'll be like, well, I looked at this thing, it wasn't exactly a good fit. And the nice thing is that they don't know if it's exactly a good fit. And you go, okay, what's your gut feel on it? How much does it look like? Is it interesting? How hard would it be to build something that's similar? And that time boxing generally prevents them from like laser focusing too much on how interesting the tool is and thinking more about, holy crap, how do I solve this problem in 3 hours?
So how about selecting tools? So the good thing about IT consulting is that you can, every new project you can start almost from scratch. You can select a new, well, you assemble your team. You pick the number of tools you want to use. Well, even if it's a brownfield project, you might have just received some bits and pieces of source code, and you need to build your build automation on top of that. Seen that? So some notes there. Okay. So that's the good side of IT consulting. On the other side of things, when you then pick a technology that will affect the IT operations side of things, you're in trouble. It's not on a technology roadmap of your customer. There's probably no chance to get it in. You need to have really good arguments, a good case study, maybe worked with that before in a small play project that you can show to the customer. If it's open source, then the chances are a lot better to get it in, at least to try it. Sometimes, yeah. I know a very good tool for log management. The bad thing is it costs about $1,000 for as many nodes you want, as many whatever, but it costs $1,000, and yeah, and then you have to start a lengthy process. So open source usually helps. Anybody see anything else in technology selection that I forgot? I think that's the most. Yeah.
All right, guys, thanks. So what we like to do is just open it up for questions and answers. If there's anything that you guys heard today or things that we didn't get a chance to talk about, if you guys want to ask, then we've got pretty varied experiences and backgrounds up here. Their use of Salt. There's things that you guys would like to ask about. I think now would be a great time for some Q&A. We've got a couple mics floating around in the back, or one there, and I'll split the room with you in half, I guess. So anyone have any questions for these guys with regards to their backgrounds, things that they talked about? So here you go.
This is directed at Eli. You mentioned that you view things as being that you should pass the IT role to the developers, that we should not have an IT intermediary between the developer and the resources. Do you think that the decoupling of resources as not being finite, like data sources, ability to access data stores, that the way that cloud is decoupling those from being finite, or at least seeming like they're not finite, plays into that when resources are finite, there's a greater need for that IT intermediary?
Oh yeah, absolutely. Back when we were, requisitioning servers and standing them up and stuff like that, there was a very real constraint. Even if a developer came and said, okay, we're going to release this new initiative, we need, 10x capacity on the database, and it's going to make us 100x in profit. It'll be amazing. Like, there was very real latency there where we had to get the stuff requisitioned and stood up and hooked up and QC to make sure it's all there. And we really don't have that anymore. If I want to, I can go to Google and spin up 1,000 cloud servers in like 5 minutes. I can do it from my laptop in this hotel right now, and I could just be like burning money like a madman. But I could be doing it. If there was a business reason to do it, I could certainly be doing it. And as was mentioned in the keynote, the the dissolution of distinct IT from dev is really a business and organizational decision. I think I would be very wrong in saying it's right for everybody. Where our company is very small and we have a very small engineering team, there's huge benefits for us in just passing knowledge around and being able to iterate quickly by having everybody understand what our deployment environment looks like and how they get code there. But it's not the right decision for everybody.
Other questions? Come on. We know they're out there.
I don't know how these things work. Can you hear me? Yeah. So you both, y'all have a varied background and everything. So when has it been where you've reached a line where an open source or a tool that's available didn't meet what you needed and it was more appropriate made to develop something internally? Any of y'all had any experience like that? And did that bite you back, or any lessons learned from that, or anything like that? Yeah.
I'll throw in there. There's been a couple of times actually where we have picked up an open source project because it looks like it meets all of our needs, and it doesn't, and we find this out sort of iteratively as we start to refine. I mean, when you're in the prototype stage, usually an open source project is like right there, and it's fast and you get the prototype out and that's great. But then as you turn it into a product and you start to get kind of market direction into what your users actually want, you almost always find that it's not exactly the right fit, unless it's something really, really awesome. Salt's a great example of that. But we hit a project where it was built on top of probably like 4 or 5 layers deep of open source. So it was like CoffeeScript that was implemented on top of some JavaScript libraries that actually interacted with some Node stuff, and then it just like went on down. And we got screwed because nobody in our organization actually knew CoffeeScript, and the few people who were like kind of interested in learning ended up really hating it. And we had like this piece of software that was core to this product that we had forked, and nobody was developing it upstream, and nobody wanted to do CoffeeScript. And so people started developing these hacks around the limitations of this piece of software and like doing weird things with making it interact with, say, like Nginx or whatever, and like transitioning some of its workflow into other stuff because like, oh man, this piece of software is such a pain. We would have been way better off early on if we had just said, you know what, we've got a bunch of Python developers. We don't really need to get into this CoffeeScript thing. This tool, like if we just take some time to understand it, we could probably re-implement it in not too much time. It's just really hard because you get bought into, we're going fast, hey, this is helping us go fast. It's not that bad, it's a couple days pain. It's not that bad, it's delaying us by 2 weeks. We can keep handling it. And you get so bought into the tools you've chosen that at what point do you sit down and go, no, this is not working. We need to redo this. And by that point, you've built so many features that you're like, it's going to take us 3 months to re-implement this. Let's hold everything at a standstill for 3 months. It's rough. And so I honestly don't have any solid solutions about that, except like be very careful and proactive when you pull tools in. Make sure you understand like what's the ecosystem like around that open source project. How hard is it to tap into experts? How interested is your internal engineering team in this particular technology or the implementation of this technology? Taking a day to throw one person at understanding like the architecture of a tool you bring in usually pays pretty big dividends because you make a commitment as soon as you do an import or as soon as you link against a library. You're making a commitment to, this is now a part of our organization. This is a part of our team, just like we had hired the person who wrote the thing.
Front ends are often like that. Whatever is going to be the main front end, maybe you could find something open source that's the front end to the biggest thing on the roadmap, but especially on our projects, we're integrating 6 systems. So they're all going to converge into a front end, and now we have our choice. We can take one of them and splice into their front end, or just put it aside, build a clean front end, and let that be exactly what is needed. And that's usually the way to go.
I've built, or my teams and me have built software to, for example, do database deployments by themselves. Or database migration, or whatever, new packages, new tables. So we did it ourselves, and as there were no real good tools on the market. We also did the same for deployment. We wrote big shell scripts to do deployments automatically. At that time, it was the right decision to do that, to do a simple solution that just worked because there was no good solution available. But there's always another point in time where we then should throw away the solution that you built on your own, because the new open source software that is available, that is well maintained, that has a community, that you actually should do the switch to that open source software, because people that come into your project know the open source software better than your homegrown stuff. And a lot of people don't do that, and that's something I'm more concerned about.
Questions?
Yeah, can you guys talk about experiences you might have had going from a production deployment process that did have an IT ops handoff to one that didn't, and what worked well and what didn't during that transition?
I really wish I could. All I've ever seen are organizations that start out going, "Yay, DevOps!" and they lack the discipline, and they end up going, "Oh man, like everything's getting delayed because nothing's getting shipped when it should. Maybe we should just hire someone who knows a whole bunch about how to actually deploy stuff." And then, like, once you make that step, we've hired the IT guy. It's generally all over because they're so expert, and everybody just wants to rely on their expertise, and that's their job full time. And so they just tend to like grow and grow, and then they go, "Oh, I need a helper. Oh, now we've got an IT department. Awesome." I've seen that a bunch of times. I have never been a part of the reverse, unfortunately.
Those are very interesting because you have resistance from the ops team that is sitting there going, "But what do we do?" And you have resistance from the dev team who's like, "Well, somebody else does this." So there's a certain amount of give them the tools, make the tools as pretty, as nice as you can, and then tell the developers, push it down from management if you can get a strong enough mandate. Okay, ops is not answering your email about this. They will do this from this point, which is the handoff. And there's some pain. There's a significant amount of pain. Yeah, you may just hire the ops guy. But frankly, I would transfer the ops guy from ops to development, and at least then you have an ops guy in the dev team. And now
That's the right way to
some
go.
diffusion.
Yeah, if you move your ops guys around, that can be very effective. That's a good point.
Any comment?
A small comment. If you want to do DevOps, really, you need to have, hopefully you have a company small enough that everybody knows if this is not going to ship, we will have a big problem financially wise with our company. If you're so big that it doesn't really matter to the single developer, to the single IT operations, then it's really, really difficult to get that in place. Even with management support, that might get you one step, but not to the real goal.
But a big organization can still generate the same pressure about shipping. Point taken, but
okay.
Still, this is going to ship or we're all fired.
Haven't seen that yet.
Yeah, definitely. And if anyone wants to chime in on that, I'd be happy to pass the mic there too. I think these are the types of discussions that we certainly want to give folks a willing volunteer. Yeah, there you go.
Are you doing that from the I have to ship standpoint, or from the hey guys, I got news for you?
I'm doing that from the hey guys, I got news for you. Brief background. Guys on the dev side have basically spent the last 5 years writing box software. And a year ago they decided we're not going to offer it as a service. SaaS. Yay. This is one of those situations where the code was not launched, it escaped. And we have a very large deployment coming on Monday, and they've been very time pressured. There's been no management support for DevOps. So I'm actually really curious, being an old, and I mean old school, waterfall type tech ops kind of guy, how you bring that culture into an environment where they're so orthogonally opposite, where you've got developers saying on a Thursday afternoon, well, you know, I don't have time to to test in development and QE. We're gonna throw it in staging and bake it for a week. So how do you address that? I'm curious.
The best techniques I've seen come down to metrics that provide responsibility. So if you ever want to see somebody have a brown pants moment, walk into one of your sort of mid to senior developers with a pager in your hand, set it on their desk, and say, I have set up 3 metrics. This pager will go off if one of those metrics is violated. Those metrics are on your code.
This is a case where a release or testing engineer can also help a lot, especially if they have any ability to loom. You know, if someone's watching the code, if somebody's sitting there and they will be the person, and you know, if they have a quiet time, they're going to add 6 more regression tests. They're gonna, you know, go, okay, well, we're over 1,000 tests now, you know, and things will kind of move forward. And when something comes up in staging, because they pushed it there and they thought they were going to let it bake, well, now there's a test for that. Hopefully that the developer wrote, probably because the release or testing guy said, now you must also write the test, and I'm watching. But there's a test. Maybe he writes it himself. There's a test, and you won't have that one again, and you won't have the next one again, and you won't have the next one again. You may even manage to adopt test-driven development. Maybe. At least test with commit development will push you that way.
Like you start on a Monday building a new piece of software, so that's greenfield development. The Monday after that, it's no longer greenfield. So if you have forgotten or not cared about writing testable software, then you're in trouble when you want to do continuous delivery or any kind of automated delivery. I have been in or partly through that pain of taking over an old code base and making it testable. That's really hard. So I don't know, education might help. Feeling the pain might also help, but feeling the pain is when you have a legacy software, put that into production and you have all these bugs and say, okay, maybe next time I should do proper testable software from design. The thing is, it doesn't usually help the software that's currently in production. It might help the software that you design next time. So either you throw a lot of money at that old legacy software, or throw it away and build something new.
The other thing to note, if you're putting tests on old software, write any test. Write a nice big integration test. Don't go, a lot of advice will say go do unit tests, like unit test everything. You'll be forever, your code already exists.
Unfortunately, we're up against our time right now. I hope that you guys will get a chance to introduce yourselves to each other. I think that's part of the benefit of this conference is just, I think it's a really easy place to trade some information and be able to keep these conversations ongoing. If you guys have the mobile app, certainly appreciate it for these guys too, if you guys are able to just log in and do a very short survey for them. And then lastly, before we break for lunch, if we can just give these guys a big hand for giving up their time.